So here there's some dose calculation. So the following is an overview of the steps you should take to complete each dose problem. The rest of this tutorial will explain how to perform each of these steps. First, dose question steps. Determine the problem types like mass for mass, mass and liquid for liquid, amount in IV fluid, volume over time or IV milliliter rate, volume over time IV drop rate, fluid maintenance requirements, dose by body weight, and also mass over time IV milliliter rate. Identifying what is the value of each variable in formula and make unit consistent as necessary, and also fill in value for formula and solve the problem. First one, mass in mass. So here we go and explain. First of all, mass for mass questions. Given an amount of mass per tablet, how many tablets do you require? So, desirable number of the tablet, right, equal to doctor orders or doctor's prescription over or divided by pharmacist, order or medication in hand, or what pharmacy gives us. Order divided by what we have. So what is doctor order? If you divided what we have in hand, we will get the number of the tablet. Example, metoprolol. It is the hypertensive medication. Doctor prescribed 25 milligram orally in order, right? Doctors prescribed. Metoprolol is available 50 milligram tablet, but doctor gave 25 milligram. How many tablets would the nurse administer? So total number of the tablet equal to doctor's orders 25 divided by medication available in hand, right? So if we divided it for 25 divided by 50.5 tablet we need. This is the answer. Keep it note, in NCLEX board exam, they will not give the phone number. No, it should be empty the space. You have to fill it up, fill it out. You have to write the number. They will not give you the 4 option. Will not, I think. Another example here. So potassium chloride is available as 10 milligram per tablet. Potassium chloride, it is called KDUR. 40 milligram is ordered. So doctor ordered or doctor prescribed 40 milligram. And the medication pharmacy provide or medication in hand, 10 milligram per tablet. How many tablet? Number of the tablet, doctor order, divided medication available, means 10 milligram. 40 divided by 10, 4 tablet. Another, here we go. Liquid here, mass divided by liquid for liquid questions. So given an amount of mass per liquid, how much liquid do you require, right? So keep it note, amount of mass per liquid. So this is the question, add something, liquid. How much liquid do you require? So we actually called this called volume formulas. So required medication in liquid equal to doctor's order divided by medication in hand or available and multiply volume perhaps. So example, phenytoin or other name is called dilantine, 0.1 gram orally is ordered. So doctor order is 0.1 gram ordered to be given through a nasogastric tube. Phenytoin is available as 30 milligram per ml. So it is liquid volume per we have. So it is 5. How much volume the nurse admin? So here's something important you have to know. So phenytoin is available 30 milligram and doctors order 0.1 gram. So gram unit we need to convert to milligram. So how to convert gram to milligram? So the convert 0.1 gram to milligram, it is the formula said. So 1 kg converted to gram, and gram converted to milligram, and milligram converted to microgram. So you have to multiply 0.1 gram by 1000 because 1 gram equal to 1000 milligram. You have to multiply because a big number going to convert to small number. So it is 0.1 times 1000 equal to 100 milligram. So doctors order 100 milligram phenytoin, medication in hand 30 milligram, and it is liquid. So multiply by volume per hand, it is 5. So we are allowed to use the calculator during the exam, so we can use it. So 100 times 5 divided by 30, it should be 16.7 milliliter. This is how much would the nurse admin. Another example here. So example, ordered Lasix, it is the diuretics, 40 milligram IV push now. So doctor's order is 40 milligram IV, available 80 milligram in 1 ml. So it is liquid formula. How much will the nurse draw up? So requirements medication in liquid equal to doctor's order divided by medication available and multiply volume per have. So 40 milligram is doctor order, 80 milligram we have in hand times 1 ml. It should be 0.5 ml. We need to admin my patients. So now let me show you about how to unit conversion, important for board exam. So here talking unit conversion. So microgram, if you want to convert milligram, milligram want to convert gram or gram to kilogram, always divided by 1000 because 1 milligram equal to 1000 microgram. 1 gram equal to 1000 milligram, and 1 kilogram equal to 1000 gram. So when any small number converted to big number, always divided. But if the big number converted to small number, always multiply. So if you want to convert milligram to gram, gram to milligram, milligram to microgram, total number multiplied by 1000. So if you want to convert pound to kilogram, it would be divided by 2.2 because 1 kilogram equal to 2.2 pound. If you want to convert kilogram to pound, it will be multiplied. Volume formula: microliter, milliliter, liter, and kiloliter divided by 1000. But if the big amount converted to small amount, multiply 1000. Same as time. If you want to convert minute to hour, total number will divided by 60. But if you want to convert hour to minute, multiply by 60 because it is a big and minute is small than hour. Example, convert 5000 microgram to milligram. So you have to divide it by 1000. And 5000 divided by 1005 milligram. If you convert 44 pound to kilogram, and we know 1 kilogram equal to 2.2 pound. So 44 will divide it by 2.2, and it is 20 kilogram. Right? Another example here we see. So convert 0.003 liter to microliter. So microliter equal to milliliter, liter, and kiloliter. So if you want to convert big to small, multiply, like 0.003 multiply 1000, 3 liter, right? And 3 liter times 1003 MCL. Convert 5 hour to minute. So a big number convert to small, multiply or times by 60. 5 hour times 60, 300 minutes. So this is the very basic about unit conversion. Now go and check. So now I'm going to show how to amount of IV fluid, how we calculate it. So here, so given a volume of IV fluid and a dose expressed in percent, what is the mass of a particular doses? Let me recap it. This is the formula we use, amount of IV fluid. So given a volume of IV fluid and a doses expressed in percentage or percent, what are the mass of particular doses? So formula said concentrations percent divided by 100 times volume. So equal to, we'll get the dose amount in gram. So what are the mass of a particular dose. So dose amount in the gram equal to concentration percentage divided by 100 times volume. Example, calculate the amount of dextrose in 1000 ml for D5W, means dextrose 5% in water. So I like to request you just focus in the number, like how much dextrose, 1000, and this is the volume, liquid volume, and percentage of dextrose is 5. This is the concentration, 5%, and formula said 1000 should be constant. So concentration is 5, 100 is constant, and volume is 1000. We get it from the questions, and we will get the mass of a particular dose amount in gram, 50 gram. Another example here, calculate the amount of sodium chloride in 2000 ml. So this is the volume, normal saline, and normal saline strength or concentration is 0.9% sodium chloride. As I told you, 100 is constant according to the formula. So concentration 0.9%, volume is 2000 divided by 100, so it is 18 gram, and this is the sodium chloride, right, amount, dose amount in gram, 18 gram. Now we are going to go volume over time formulas. So here, so given a certain amount of liquid and a time period, what is the necessary IV flow rate in ml per hour? Measurement used when IV regulated electrically by infusion pump. So this is the formula we use for infusion pump, or we call IV milliliter rate calculations. So flow rate, and definitely this flow rate formula in express milliliter per hour, not a minute. It is important, give a focus. So volume always in unit milliliter, over that time must be in hour. So if it is in minute, you have to convert to hour. So example, infusion 250 ml over the next 120 minutes. So this is the 20 minutes, you have to convert hour because of formula. So by infusion pump, so we need to know what are the flow rate in ml per hour. According to this formula said, volume is 250 divided by time, and time is here 120 minutes converted to hour. So how to convert 120 minutes in hour? Convert 120 minutes to hour, minute, convert to hour, divided by 60. 120 minutes divided by 60 means 2 hours. So 250 ml divided by 2 hours, 125 ml per hour. And this is the flow rate in ml per hour. It is called flow rate formula, volume in millimeter and divided by time in hour. Express the unit is important to get an accurate answer. Another formula here, say, ordered 1000 ml dextrose 5% water IV to infusion in 10 hours. So time is expressed 10 hours, and we need time by hour according to formula. So volume is here, 1000 ml. Time is 10 hours. So what are the flow rate? Infusion pump means flow rate in ml per hour. 1000 divided by 10, 100 ml per hour. Next formula, we talk IV drop rate. This is the formula IV milliliter per rate or flow rate in ml per hour or infusion pump volume per hour. But volume over the time, little bit different formula. What we need to IV drop rate count. In this formula, we use the time in hour, but this formula time will be expressed in minute. Let me show you. So volume over time, IV drop rate questions. So given a certain amount of liquid, a time period, and drop factors. So it is important when you practice this formula, it is important to compare with this formula. This is the volume over time in hour, we called IV milliliter flow rate formula. This is volume over time, but in minute, it is called IV drop rate. So given a certain amount of liquid, a time period, or drop factor, the unit is called GT per ml, is called drop factor. What is the necessary IV flow rate in the GTT as per minute? Measurement used when IV is regulated manually, because it is not possible to give a patient a fraction of a drop. It is usually to round number for this problem up or down to the nearest whole number. So when we get any fraction number, it is good to go nearest whole number. According to the formula said, the flow rate in drop factor unit is GTT per minute equal to volume in ml divided by time in minute times drop factor. So if you ask me, what are the difference between this drop factor and this? This is drop factor, what's supposed to mention in the question. Drop factor unit is GTT per ml. But the flow rate in drop factor unit is GTT per minute. So only difference here and here. So if you do not give the concentration, what I'm saying, or if you do not give concentration when you're practicing, if you do not give the concentration when you read the question in NCLEX board, the chance to lose the point. So it is called flow rate formula in drop factor GT per minute equal to volume ml divided by time in minute times drop factors GT per ml. That is always mentioned in the question. If not, then it is good to put 1 and you will get it. Example, calculate the IV flow rate for 1000 ml. So this is the liquid, means volume, and solution is called saline solution. to be infused 6 hours. So hour have to convert it to minute according to formula. The infusion set is calibrated for a drop factors and 15 GT per ml. So just give the look here. Is it ml or is it minute? If it is ml, means drop factor. If it is minute, it is flow rate drop factor. So volume is in the question. Time is minute, but it is in hour. Convert 6 hours to minute. When a big number to convert small number, always multiply by 60. 6 multiplied 60, 360 minutes. So 1200 ml divided by 360 minutes times 50 and GT per ml. That is the mention in this question we call drop factors. Calculation the 50 GT per minute. So it is very important to see, is it ml or it is minute? If it is minute, flow rate. If it is ml, drop factor. So always the number you will get in question, you have to pick up and put in the formula. Another example here, calculate IV flow rate for 200 ml of 0.9 sodium chloride IV over 120 minutes. An infusion set has drop factor of 20 GT per ml. So volume per ml divided by time per minute and drop factors GT per ml. So the flow rate in GT per minute, 200 volume times, it is already mentioned in minute, so you do not need to convert because the formula said minute formula, 120, and drop factors is 20 because it is ml factor, not a flow rate. Flow rate should be minute. So 20, it is 33 GTT per minute. This is the flow rate factors. What next? Next here, fluid maintenance. So the fluid maintenance formula requirements questions. Given the body weight of a child or infant, calculate the necessary amount of fluid per day. Different hospitals may have different policies, but for learning how to perform this pediatrics dose calculations, following commonly used table of fluid required may be used. So let me recap it. It is called fluid maintenance requirement formula. Body weight range, required daily fluid. So if our pediatrics children or patient 0 to 0.0 kilogram, required daily fluid 100 ml per kilogram. 100 ml per kilogram. So if my baby is 8 kilogram, it should be 100 ml times 8, right? Then should be total 800 ml liquid need for 24 hours. If my baby 10 to 20 kilogram, they need 1000 ml plus 50 ml per each kg above the 10 kilogram. So 1000, if my baby have a 20 kilogram, so 50 milligram per each kilogram will be at. So 250 plus 50, 2 times, right? After the 10. And if the body weight is 20 to 70 kilogram, 1500 ml plus 20 ml per each kg above 20 kilogram, right? So it just depends. Is it 30, 40, 50, 70? So 20 ml per each kilogram above 20 kilogram. If over the 70 kg, it is 2500, means adult requirements. We have to memorize it. Example, an infant body weight 4 kilogram, means it is here 400 ml per kg. So it is 100 times 4 kilogram, because my infant body weight is 4 and 100 ml per kilogram body weight is, so 0 to 10 kilogram, 100 ml per kg, 4 gram times 100, total need 400 ml body daily fluid required if baby has 4 kilogram body weight. Another example here, an infant body weight is 30.8 pound. So first of all, pound need to convert to kilogram because it is the formula said kilogram. What is the required IV fluid rate in ml per hour to maintain proper fluid level? So convert 30.8 pound to kilogram, divided by 2.2. So 330 divided by 2.2, it is 40. So a small number converted to big number, so it is divided 2.2, because 1 kilogram equal to 2.2 pound. So pound converted to kilogram divided. So how much total? 14 kilogram. So following this formula, 10 to 20, 1000 ml per 50 ml per each kilogram above 10. So 50, total is 14. So it should be 50 ml per each above the 10. So 14 minus 10, it is 4 kilogram. So there are 4 kilogram over 10 kilogram. 4 kilo over 10, right? How much more than 10? 4. So 1000 plus 50 each kg above the 10. So 4 times 4 kilogram, it is total, 200, right? So 1000 plus 200, 1200 milligram per day need. So this is the pediatrics dose. So this is now ordinary IV flow rate in ml questions we have to follow. Record the volume 1000 ml. So now when up to get this, but question said proper fluid level. So flow rate formula need to follow. Flow rate formula equal to volume ml, right? IV flow rate in ml per hour. So volume ml, there are 24 hours in one day. So 1 day times 24 hours. So 1000 divided by 24, 50 ml. per hour. And now go another formula called dose by body weight. Next formula here, dose by body weight. So here, given the weight of a patient body weight and a dose specified in terms of weight, and calculate the necessary doses. And this problem are type of pediatrics dose calculation. Formula said body weight in kilogram and dose per kg equal to required doses. So this dose for pediatrics, right? So required dose equal to body weight in kilogram times dose per kilogram. Like example, a doctor ordered 200 milligram of roxapine to be taken by 15.4 pound infant every 8 hours. The medication level shows that 75 to 150 milligram per kg per day is appropriate dose range. So is the doctor order within desired range or not? We know that required dose equal to weight in kilogram and times dose per kilogram. So we have to convert 15.4 pound to kilogram. So it is need to divide it 2.2 because small amount, small unit need to convert to bigger unit. 15.4 divided by 2.2, 7 kilogram. So body weight in 7 kilogram, dose per kilogram, 75 to 150 is the range. Minimum 75, maximum 150. So if you calculate minimum 7 kg times 75 milligram per kg, 525 milligram. This is minimum desired dose. So if you give the medication less than this medication will not work. And maximum dose, 7 kilogram times 150 means 1050 milligram maximum desired dose. If you give more than this, medication will be toxic, causes poisoning, overdoses. So the range is 525 to 1050. So they said is the appropriate dose range. This is the range. Is this doctor's order within desired range? So 24 hour in one day, and the medication is ordered every 8 hours. 24 over 8 hours equal to 3 times per day doctors order medications. So 3 times per day. So what we get, it is maximum or total doses, maximum desired dose. 24 one day, and medication is divided 8 hours. So how we get it? In this question, you say every 8 hours. So total dose supposed to be divided by 8, 3 times per day doctors order medication. So 200 times 3, 600 order total doses. right? And 600 milligram is within desired range, 500. So minimum and maximum, this is a total dose. Yes, it is per day for 3 times. Another example here we read another medication we prescribe 1.5 milligram per kilogram is ordered for a child body weight 78.8 pounds. So it is pound, need to convert to kilogram. The medication available 125 milligram per ml, so liquid formula. How many ml must the nurse admit? So first of all, body weight in kilogram divided dose per kg. So it is the required doses. Convert pound to kilogram. So pound, when you convert to kilogram, divided by 2.2, 74.8 divided by 2.2, 34 kilogram. So 34 kilogram times 1.5 milligram per kg, because this is the doctor's order, 1.5 milligram per kg body weight. So if my children is 34 kilogram, means 34 multiply 1.5 is total kilogram or milligram, 51 milligram. So this is now ordered. We have to follow. When we got total amount doctor orders, we have to follow mass liquid formula because it is mentioning liquid. So doctor's order 51, medication available 125 times volume per we have equal to liquid requirements. So two formula put together, calculate total accurate number answer. So total doctor's order 51 divided by medication in hand 125, and it is liquids 2 ml. Answer is 0.82 ml. So this is the design. Another formula we use, it is called mass time formula. So what is mass over time formula? Given n, a formula equal to IV milliliter rate. So give an order in quantity of mass per time. Determine the necessary IV flow rate in ml per hour based on given mass per volume. This type of problems are often used in critical care nursing, right? So this formula is called mass over time IV flow rate formula. So flow rate in ml per hour, ordered per hour, medication in hand, times volume in ml. Example, give the patient 500 milligram of dopamine in 250 ml and 5% dextrose in water to infuse rate 200 ml per hour. Calculate the flow rate in ml hour. So flow rate in ml hour formula, ordered per hour divided by time, what are the available times volume per ml. So flow rate we will get it. So here ordered per hour, it is 20 ml per hour. So it is the unit. So check the unit, put the number. And medication in hand, Patient, give the patient 500 ml dopamine, 500, and this dopamine 200 ml liquid volume in ml. So when you calculate this one, answer the 10 ml per hour. So another example here. So like, so here, and medications 12.5 milligram in 250 ml prescribed to be infused at a rate 6 microgram per kg per hour. It is a little bit complicated. In a patient whose body weight is 100 kilogram, at what flow rate in ml per hour will you set the pump? So flow rate in ml per hour, because it is the, what are the flow rate in ml per hour? We have to follow this formula. It is mentioning here. Order in hour divided by half times volume. So ordered per hour, it is the first steps is to convert the order per time to amount required for this particular patient. So this is the dose by weight formulas. 100 kilogram in weight in kilogram and 6 microgram per kg per hour is dose in term of kilogram. So weight in kilogram times dose per kilogram, and it is called required doses. Required dose means weight in kilogram times dose in kilogram. So 100 and 6, it is mentioning in question 6. This one is dose per kilogram, and it is body weight is 100. So this formula will require dose 600. So 600 microgram need to convert to milligram per hour because of formula. So small number converted to big number. So divided by 1000, it should be 0.6 milligram per hour. So this is the order per hour divided by what is the medication in hand, 12.5. And volume is 250 ml. So it is 12 ml per hour is the required. So this is the formula we discussed right now. First of all, those question steps. You need how to convert the different in unit, we call unit conversion. Then we check mass for mass formula, mass and liquid for liquid formula, IV terms and abbreviations. Yeah, amount of IV fluid, how to calculate volume over time, IV flow rate formula, volume over time, but in minute, IV drop formula, fluid maintenance formula, doses by weight calculation, mass by time, IV milliliter flow rate, right? And here I said some terminology, okay? So this terminology, we will learn what are the following overview, the key IV concept which are useful for those calculation problems. So GTT means drops. Drop factor means number of the drops per volume of IV fluid. It is varies and depends on tubing used, usually measured by GT per ml, drop factors. Flow rate. So measure of the flow of fluid from an IV, usually measured in GTT per minute. So how many drops are released every minute? Or in ml per hour, how many ml flow through each hour? GTT and minute is usually for manually regulating an IV, while ml per hour is used when utilizing an electronic IV regulators. So now important abbreviations means D stand for dextrose, W for water, S for saline, N as for normal saline or 0.9% normal saline. RL or LR means stand for lactate ringer. It is the drug of fluid for burn patient. Example, 5D5W means 5% dextrose in water or 5% dextrose in aqua. D5 1/4 normal saline means 5% dextrose in 0.02 to 5% saline solutions. So this is the very basic about those calculations.